So the last thing for this unit is about solving log exponential word problems. Again, this worksheet doesn't have anything that you have to fill in the blank because there's lots of things that, as far as notes and stuff. But this is stuff that there are a lot of formulas and a lot of things that you can do to solve. There's some key things that I want you to be able to do. And so there's formulas here that you've probably seen before, because I know we've done growth and decay in Math 2 and compound interest in Math 3. The only thing that's probably new here is this continuously. So the formula for growth and decay is A equals P 1 plus R to the T. Not highlighting here. What's going on here? So this, and the plus sign means growth. And then A equals P 1 minus R to the T, and the minus sign means decay. So this formula here is probably new to you. This means anytime you see this E in here, this means compounded continuously. And E is basically just a number. We talked about it before. E is the number 2.71828 ... It's a irrational number. So the most common formula you're going to probably be using is this formula here: A equals P 1 plus R over N times N raised to the N times T, where N is the number of times that the interest is compounded annually. So if you do it yearly, it's 1. If it's quarterly, it's 4. If it's monthly, it's 12. If it's weekly, it's 52. And 365 is daily. Now, A, P, R, and T are all the same for all of these other formulas. A is the amount you end with. P is the principal or the starting number. Sometimes they call it the initial amount. Initial, like, your initials are the starting amount. So the initial amount. R is the rate as a decimal. If you divide the percent by 100, you'll get that as a decimal. And T is the time. So I've given you all these directions on how to solve for A, P, R, and T. This is how you would solve by hand. Okay. Do you need to be able to solve by hand? For those of you in the honors class, probably. There's lots of things that you should be able to do by hand. But when in doubt, you can always plug it in your calculator, which is what these things down here for. So these are your calculator methods. And this is what I'm going to show you today, okay? So I'm going to show it to you in your regular calculator, and this is mostly your Desmos because most of you are using Desmos. All right, so let's talk about these examples. So you got to be able to pick out from a word problem. Sometimes they give it to you as just basic numbers, and sometimes they give it to you as a word problem. So Maria opens a saving account with an interest rate, so this is R, of 2.45%. Compounded quarterly, so that means that N is 4. If her initial deposit is $250, so that means that's P, and she makes no other deposits or withdrawals, how much money? So how much money, that's what we want to know. That's A, that's the stuff we don't know. Will she have after 10 years? Years is time, y'all. All day long, T is time, okay? So now we have all of our things. So we're going to go back to our formula. So A is what we know, what we want to know. P is 250. It says 1 plus, let's put our formula up here. A equals P 1 plus, if you can't read it, R over N, right? It's up here, raised to the NT. So we'll write it down here so you can see it. R over N raised to the N times T. Okay, so R is 2.45. Well, that's 0.0245. N is 4, and 4 times 10. Now, because we have A equals, that means there's no variables here. So it's something equals this. So this is all numbers. So we can take all these numbers and plug them right in our calculator. So we're going to put this right in our trusty calculator. And so we're going right over here to Desmos. and we're going to put it right in our calculators. So we do $250 and put it in exactly how you see it. Parentheses 1 plus, it says 0.0245 divided by 4. And then that's raised to the n times t. Well, here's where you got to be careful. Either you have to put n times t in parentheses here. So you got to either use your own parentheses here, 4 times 10, or you got to multiply what 4 times 10 is. If you don't, when you put the 4 in and then hit it, and then do the 10, it's going to multiply it at the end. So if I hadn't put that parentheses there, it would, let me show you what it would have done. It would have said 4, and when I do the times, it would have made it bigger. It would have come down to the bottom. And it would have brought the 10 to the bottom. But I don't want the 10 at the bottom. I want the 10 at the top. So I want to make sure that I put those in parentheses as well. So 4 times 10, okay? Much different answers here. So 319 and 17 cents. So back over here, A equals, and remember we're talking about dollars and cents. So that's what we want to round it to, 319 and 17 cents, dollars and cents. So she put 250 in and she got $319.17 back. All right. Calvin received $100 for his 13th birthday. Well, that's the amount he started with, right? If he saves it in a bank, that compounds continuously. So that means we're going to use the formula A equals PERT. How much money will he have in the bank by his 16th birthday? So that means we want to know what A is. We don't know what R is. This is not a good question because I forgot to give you R. That's bad. So let's say that R is 2.5%. Bad, Miss Smith. I'll fix this problem. 2.5%. And then do we know what T is? Well, it started on his 13th birthday and now it's his 16th birthday. So T is 3 years, right? So P is 100. So A equals 100. E to the R, which I forgot to put in this problem because I'm a dingleberry, 0.025 times 3. Right? Gosh, that's not writing good. Let's put a time sign there, 3. So we go right to our trusty Desmos. And we tell Desmos to put it in exactly like we want. 100, parentheses. Well, we don't need the parentheses there. We can. We go ABC, E, raised to the, here's where the parentheses need to come in, 0.025 times 3. And our answer is 107 and 79 cents. So 107 and 79 cents. Okay. All right. Next problem. It says how much money has to be invested in an account that pays 5.2%. So there's your rate. Compounded monthly, so N is 12. For 12 years, so T is 12. For an account to be worth 200, so this is the ending amount. So we want to know how much is going to be invested. That's our question mark here. Okay, so we're going to say 200,000 equals P, 1 plus 0.052 over 12 raised to the 12 times 12. Now, when we're solving for P, what does it say we're supposed to do? Well, if we look up here, it says when we solve for P, plug in all our known values, put y equals a in one equation, and find put in X or whatever variable. It's just easier to use X as our variable, okay, for P. So we're going to put that right into our Desmos equation. So we're going to clear this out. We know that A is 100,000. And our equation is, we don't know what X is, right? That's our P. And it's 1 plus 0.052 divided by 12. Then we're going to raise that, don't forget your parentheses, to the 12 times 12. Now, you'll see that the black line here, this black line, is the equation. Well, we're looking for this purple line, this 100,000. We have to find where these two lines cross. So we got to get to 100,000. That's a long way up here. So we got to find the purple line. Oh, there's the purple line. So we find where those two lines cross, and that's at 53,651,97 cents. So our answer is 53. So P equals 53. I can't remember that number. 651.97. 651.97 cents. So we would have to put $53,651.97 to get $200,000 out. Okay. So Y equals that side and the other side. So Martin bought a painting for $5,000. It expected to appreciate at a continuous rate. So A equals PERT of 4%. So this is R. This is P. How long will it take the painting? So this is A, and it says how long. So this is, we want to know the time, right? So we know that 63.56.25 equals 5,000. 1 plus, no, not 1. We're doing PERT, sorry. PER is 0.04. I'll move this A out of my way. 0.04 T. So this is A. Okay. So we're solving for T. We're going to do just like we did just a minute ago. So 63.56.25 is our Y equals. So Y equals 63.56.25. And we put in $5,000. Oh, that's too many zeros. And then we get E. And we raise that, don't forget your parentheses, to the R, which is 0.04 times X. That's the variable we don't know. And so that's blue, and we're looking for 6,000. So we're finding where the blue line crosses the red line, which is right here. And if you're not sure, you can zoom it out a little bit here. There it is. And so it says 6. So it would take 6 years for this to work. So T equals 6 years. So the Smiths bought a house for $75,000. So this is P. Assuming that its value will appreciate 6% per year, how much will the house be worth after 10 years? So if we're just talking about appreciating, this is growth, okay? So we say we're looking for A. So 75,000, A equals 75,000. 1 plus 0.06 raised to the 10. And so we have all numbers here. So we just plug that right in our calculator. So we do 75,000 parentheses 1 plus 0.06 raised to the 10. Type 10. Go away. And you'll see 134,313. 134. A equals 134,313 and 58 cents. So depreciates, that's decay. So a $40,000 car depreciates at a constant rate of 12%. So this is the P, this is the R. How much would the car be worth in T years? So $40,000, 1 minus 0.12 to the 9. Here's A, that's what we're looking for. So plug that right in your calculator. So 40,000, 1 minus 0.09. Oh, sorry. 0.12 raised to the 9. So 12,659 and 14 cents. 12,659. Last one here. So again, we're talking about depreciating. So 25,000 depreciates at 12%. We want to know when it's going to depreciate to 100,000. So that's our R. So we're going to do 100,000 Y equals 100,000. We're going to do 250,000. 1 minus 12%. We don't know when, so that's our X. And we would find where this line crosses 100,000. And that point would be 7.168. So R equals 7.168 years. So that's all you would do to solve these. Just find what the answers, what the each of the numbers stands for, plug them into your formulas, and then plug them into your equations. If all your numbers are on one side, just plug it all in. If you have numbers on one side and variables on the other, then plug this in, Y equals, and plug this in the other side and find where the two lines cross. That's all you do. Thank you.